Hello, everybody, and welcome to this CluedIn webinar on building a company data foundation. Today, we'll be focusing on how we, from start to finish, how do we build a data foundation, also sometimes referred to as the connected enterprise. My name is Tim Ward. I am one of the engineers at CluedIn, and I look forward to taking you through some of the technology and some of the decisions, and maybe some of the problems that usually come up when trying to establish a data foundation at your workplace. So let's begin. Let's start with the problem set. Now, we all know as enterprise businesses that data is pretty much scattered across the business. And in some cases, there are some data sources, some systems that have been with us for so long that are outdated on old versions. We don't trust the data in these sources anymore. And unfortunately, the typical way that we take these types of situations is we ignore them. So obviously, we're missing out on some of the value that we could get from the data that exists within those platforms. Now, if we head over to describe what is the connected enterprise, what is a data foundation? And the best way to describe the data foundation is a new level of abstraction. So let me explain. If you're a company and you're wanting to buy a database today, so just any type of database technology is okay, you don't have to now go out and buy separate querying engines and indexing engines and storage and backup recovery types of engines. You buy a database because that database has essentially abstracted the common functionality, the common types of features that are necessary to fuel a database. And, thank God we don't have to think about those, because if we did, the landscape we would have to navigate in the data world would be even more immensely larger. So the idea behind the data foundation is to take what are the common types of things that we do on every single data-orientated project. And there are a few examples up the top for you, things like machine learning, things like business intelligence. What are the common steps and processes we need to go through to make those a successful type of project? And when you look at it, all of these projects involve some common things like data integration and data storage, access control, data preparation and cleaning, data governance, tracking data lineage of where the data was sourced from and where we're using it. And the bottom line is that all of the use cases that you see up the top, and actually more, they all really do the same thing. They have the same requirements. And so really the data foundation, also sometimes referred to as the data fabric, is really this new abstraction level. It's this idea that we're going to push those commonalities behind a common foundation so that we in the business don't need to repeat this work every time we're wanting to utilize our data. Now, it's not a simple landscape. It is quite a complex landscape. There are a lot of components that make up a data foundation. But really, as you can see, there's a need for a new level of abstraction, because really at the end of the day, the business should be knowing that they can access good quality, governed, scalable data across the business to be able to fuel use cases where we can add value. So what do we need to do? Well, the first hurdle is always getting the data in the first place. Now, how most of these projects start is that, first of all, we go on a discovery phase. So we go out and ask different parts of the business, and where would I find the data on our customers? Where would I find the data on our support network, our customer service? And after some digging, you might be able to find the product owners of those systems. And then the hurdle is really that we need to get that data. And what we commonly see is the way that most companies are doing this is they get a dump or a copy of that data. It might be a replicated data set that they get. And really, here's where the problem starts. There needs to be a better way to solve this around data discovery And we can't forget that it's typically not one source that we need to fulfill our use cases. It's typically a blend of multiple different systems that might be geographically dispersed. They might be across newer and older versions of the same software. They might be even across multiple different types of technologies. And so really this first struggle of data integration starts to show itself. So what are the kind of things that if you're placing a data foundation and strategizing around how you will become data-driven at your business, some of the first things you'll need to think about is, well, don't underestimate how complex integration is. This is one of those kind of topics that we often hear from companies that, really integration is something that they'll tackle. And the typical way we solve this today is very much in a point-to-point type of solution using ETL tools and designers where we need to map these different systems together. So we take two systems at a time, something like Salesforce CRM and maybe Marketo, and we need to figure out what's the ways that these two systems blend together. And it's about this point that if you've had the same amount of experience with doing this than I have, you'll realize this doesn't really work in reality. Systems don't naturally blend together well point to point. They do blend much better when we start to introduce other tools in that might have that missing link to be able to join other systems. And one of the commonalities we also see is this tendency to start placing universal IDs through all the systems. And we've also seen time after time that these projects just end in a time-consuming and cost-consuming type of process. Now, I would agree that there are parts of the integration that are quite easy. I mean, most systems are very easy to pull data from today. In fact, throw most engineers at a problem like pulling data in from a CRM system, I'm sure within probably a day or maybe a couple of days, they've been able to build a platform that can pull the data from that system. However, there is such a huge difference between this and what actually works and really stands up against the robustness that's necessary in the enterprise. So one of the first things you need to be thinking about is you need to think enterprise. And when we're building integrations to platforms, we need to know this is not going to be done with simple authentication mechanisms. A lot of these authentication mechanisms today that are industry standard are actually quite complex. Things like open authentication 2. There's quite a dance that you need to take into consideration to be able to not only get authentication to talk to systems, but maintain the authentication over time. And when you're talking about the enterprise, there is often multiple layers of security and authentication and authorization that comes into play. And this really complicates integration because not only are we dealing with connecting to data, but now we're talking about the volatility of password changes and expiries on certificates and tokens. And how do you make sure that you have a consistent flow of data that's going throughout your business? So this is one of the first things you really need to tackle. So once this being put into place, really, from a proof of concept perspective, it's not that hard to connect to accounts that exist across the enterprise. But when you are talking about enterprise customers, you're usually talking about 5, 10, 20,000 employees and above. And there is such a fundamental difference between this and connecting to a limited amount of data sources. And so one of the things we need to remember is that really when we're connecting to the enterprise, we need probably thinking more on service accounts and system account levels, not necessarily on individual people's accounts. So you won't necessarily be authenticating with your Office 365 account or your Salesforce account. You'll need to set up very specific service and system accounts that cater for some of the fragility that usually happens in the enterprise integration space. And I mentioned and alluded to some before, things like password expiries, etc. And so what you'll often find with these service accounts is that we can create higher levels of encryption, much stronger authentication mechanisms, but we can make sure that those accounts last for a very long time. So, they're not resetting passwords or expiring passwords often. And, as long as those techniques also offer a way to re-authenticate and to gain new API tokens when these expiries happen, then we can really start to think about providing a robust type of infrastructure for data integration. So we really need to be thinking about things like, what happens if we're halfway through pulling data from an Oracle database, and what happens if things fail? What if the authentication stops? What if the network goes down? Are we persisting state? Should we persist state? And there are many different times where both are actually correct. And really, we need to navigate when those times are valid or not. Now, one of the ironic parts of data integration is that you'll often hear a lot of companies today talking about real-time data and the necessity to have data as quick to the target, as quick to value as possible. Now, that's great, and that's a very valid use case. However, we can't forget that a lot of the source systems that we'll be pulling this data from have pretty strict limits on how often and how much we can pull data from them on a minute basis, on an hourly basis, maybe a monthly basis. And more often than not, these systems are very limited on the amount of access and tokens they give you on a daily basis to be able to pull your data. So there is a reality check here that, if we're constantly bombarding a CRM system with pulling data as quick as physically possible, well, usually we're talking to production systems, so we need to maintain some type of quality of service on that network. And most modern platforms today, when you're integrating them, will actually tell you that you've hit these throttling limits, or you're about to hit these throttling limits. And the bottom line is, this is still quite a complex problem to handle. It's not always very clear or obvious how many tokens you'll get a day to be able to call these different services. And you really need to handle this with a lot of care. So then, should we go real time or not? Or should we, when we're handling data integration for our foundation, should we take a classical old approach of scheduled crawling, batch crawling of data from the sources? And then really the answer is both if the systems support it. And there are many platforms today that just do not support real time in an obvious way. There are some cases where we can hijack parts of those platforms to be able to simulate real-time data, but they weren't necessarily designed with real-time data in mind. Now, the reason why we say both for this is, of course, having the data in the CluedIn system, in your data foundation as quick as possible, can obviously lead to having insights quicker. But we can't forget that a lot of these real-time systems, they work on a protocol that I guess you could describe as fire and forget. It means that really you have no guarantee in your foundation that you received that data. And this is just based off the protocols that a lot of these real-time systems that use. So I'll give a practical example. If I was to create a record in my Salesforce CRM, Salesforce supports pushing that data to locations using webhooks or push notifications. So as soon as that record is either created or modified in the source system of Salesforce, Salesforce will then push whatever is necessary over to consumers. Now, in that case, CluedIn, the foundation, could be one of these systems. Now, based on this, maybe we can be a little bit more lenient on how often we're going back to that source system, the Salesforce system, and asking for the changes in data. However, we really can't forget that we still need that classical crawling integration batch type of pulling and polling of data, really because these real-time systems are really based off this fire and forget protocol, that you really have no concept of a receipt that, you know, HubSpot or Salesforce has sent some data. There's no concept of platforms like CluedIn saying, hey, Salesforce, I received that data, so thank you for that. That's just not how these protocols work. So it's just really important that, you know, still in this day and age, even though real time is the new black, that really you still need to support your integration layer, these multiple techniques of fetching data. So the second and probably the biggest hurdle is, after we've integrated the data, we really need to clean and prepare the data. And when I talk about preparing data, this obviously encapsulates quite a lot of different topics. So let's step through that. So one of the first learnings of building a data foundation is it starts with the technology stack itself, so the data foundation. And when it comes to data foundation, there's many different layers. The first would obviously be where you're hosting your data. But we're going to focus on the actual database technologies. And at CluedIn, very early on, we realized that, you know, we can't solve all of our problems in the data world with just one database. In fact, even throwing 1 or 2, 3 different families of databases, we don't really cover the full spectrum of the types of problems we need to solve. And that's why at CluedIn, we actually use 5 to 6 different database families. And these include, but not limited to, the graph database, the search indexing types of databases, of course, a relational database. I mean, even though we're not wanting to solve all our problems with a relational database today, and we shouldn't, that it still has very, very valid use cases where it is a better solution for solving certain problems over the graph or maybe a document store. And really, the idea is, by combining these databases into a coherent, unified data layer, we can start to not only store our data that we've sourced in this purpose-fit modeling that those database families enjoy and are designed to solve, but when we go to actually use this data, we have much more flexibility around combining the power of these different databases into some pretty powerful querying. Now, I'll show you a couple of examples of that later. Now, of course, whenever I see the word automatic, I think magic. And really, when it comes to automatic cleaning of data, there really is only a limited subset of things that we can automate in the data space. And first of all, it starts with some pretty classic data normalization, data scrubbing. And, you know, things like dates, they will come in different formats from different systems. And the good thing is that the majority of date formats used by the majority of platforms, they can actually conform and resolve into a normalized representation or a consistent representation of a date format. And the most important thing we have to remember is that we're not interested really in changing the values in the source systems. We're meeting at a central hub where our job is to prepare this data for the downstream consumers, the business intelligence tool, the machine learning team, the data science team. Because really what they're doing today is mostly this type of work, normalizing, blending of data. And the bottom line is they're not really designed, those teams, to solve these types of problems. And they're really more targeted at, once I have good quality data, how can I get value out of it? So we can apply some pretty standard normalization to things like countries and locations and addresses, things like phone numbers and dates of birth. But there are some things that are tricky, like addresses. Although we can do some automatic cleaning, it's still not a known science. There is too many formats, too many heuristics, too many different versions of what could be deemed a valid address or not. So we're going to go through as much as we can automatically clean. And one of the first things we need to do to build a data foundation is actually to set the status quo of what are we dealing with. And this comes through data metrics. And at CluedIn, I've taken a few snapshots of some of the metrics that we measure on. And there are very obvious ones like completeness and accuracy and relevance and connectivity and validity. And although these sound very synonymous, in our data space, they are actually measuring different things. And what this allows the business to understand is really, what are they working with? What are they currently delivering to the forefront of business? And it's probably no surprise that this is usually a shock for most businesses of really the low level of quality that they're working with. And a lot of this can sometimes get masked when we're showing this data in beautiful visualizations. I mean, if I see a pie chart that looks colorful and beautiful, I don't necessarily think, well, what type of data is actually fueling that and what's the quality of it. But in more cases than not, we are actually usually dealing with pretty low quality data. So these metrics help us kind of set the status quo. However, they've also become really important later when we're trying to clean data in a manual approach. And the reason why I mention this is because too often, really the way that we're cleaning and preparing data is kind of in a way where we have to clean a system at a time. So we take the CRM, something like Dynamics, and some data engineers will go through and clean the data. And the bottom line is that a lot of time is wasted in this process because we really haven't identified what data needs to actually be cleaned, what is low quality. And by measuring the data coming in at a very granular level, it's very easy for systems like CluedIn to say, hey, I actually know what data needs to be cleaned, or at least what data you can clean to raise these metrics, because really it's everything that falls below your acceptable thresholds of these individual metrics. So we'll go over a couple of examples of that later. So one of the next processes that's really necessary is that, you have to understand that a business will describe data differently throughout different departments. The sales team might refer to a person as a customer. In the support team, it might be a support or a support person or a support user. And the bottom line is, in a lot of cases, even though these have different subtypes, they are essentially the same type of object. At the end of the day, they are a person. And when we're pulling in data from our integrations, what's so important is that we bring it in raw and we bring it in generic. And really, it's our job to be able to strongly type these objects to be able to understand and apply cleaning at a much higher rate. So something as simple as classification is something that's very important with building a data foundation. It's this idea of taking in a document and classifying as an invoice. Now, of course, the goal behind this webinar is not to dive into how you necessarily do this from a technical level, but just the fact that you need to be able to do this. There are a lot of off-the-shelf classification engines that will help you do this. Really, the problem and the work comes with the fact that a lot of these engines have been trained off generic data, not your data. And your data looks very different to other companies' data. A lot of time needs to be spent in improving these classification and categorization engines. So it's only at this point that we start to look into merging records. And right now, we're only looking into merging records that have a matching ID. Now, this is how most companies are doing it today. They are using ETL tools to look at multiple tools at a time. Usually, they'll take two at a time, and then they'll try to map these two systems point to point. And as I alluded earlier in the webinar, this really usually doesn't go well. And that's because systems don't blend well naturally. They sometimes need to hop between many different systems to be able to blend data properly. Now, one of the things to highlight here is that CluedIn uses a pattern of integration we call eventual connectivity. And what it solves is that we can actually take a system at a time. So if we're trying to blend data, we only need to take, for example, the Salesforce CRM, and we only need to flag on the objects what is a unique representation of this object. Once we start to get to data that's connected to that, we're not really interested in knowing how it's connected or which system it will connect with. We're more interested with that this object has a reference to something. And this is a unique reference to that something. And really the eventual connectivity pattern is there to be able to say, oh, I'll figure out what other system has that matching ID, because it could have multiple. And this eventual connectivity allows us to actually take one system at a time and remove this whole need for point-to-point type of integration. And time after time with our customers, we've seen huge success and precision with this approach. And what it allows us to do is it allows us to get to value much quicker. A couple of good examples would be one of our larger customers being able to integrate 124 applications with just in under 4 months. And this is just really unheard of in the industry, in the classic ETL type of pattern. So you can start to see why using this eventual connectivity pattern really starts to yield a lot of good results. Now, it's also at this time that we're going to not only look at the way that different columns map or properties map between systems, we're actually going to start scanning the actual values, because a lot of the time that can allude to relationships between data, and often you'll find a lot of systems that have not named their columns and properties very well. In some cases, they're auto-generated. In some cases, they might be in different languages that you can't understand. And really what you're wanting to look at, you're not so interested in the name of the columns, you're more interested in building the connections based off the values of the data. Now, optionally, at this point, we can start to use external data sources to help us out. Now, it's probably a good time to tell you now that CluedIn is really based off this design principle that data in systems is only a clue. It's not a fact. Just because you have the data doesn't mean that it's true or statistically accurate. And the same goes for a lot of these online data sources as well. Although they probably spend a lot more time manually maintaining these types of data sets, really we still can't be sure that the data is actually in any way factual. And so every single piece of data that's CluedIn ingests, it treats it as this clue, right? That maybe it's right, maybe it's wrong. And it's really CluedIn's job to be able to find how that clue is related to the rest of the business and to start building up a statistical confidence of how confident can I be with these values. And a good example would be if I have Emma here, her record, and most of the systems that I plugged in are alluding to the same email address, I can be more confident with its accuracy. If all of those emails are in a standard email format, well, I can also be more confident with the quality and uniformity of that data. So it's at this point that you can optionally choose to enrich from these external data sources. Of course, CluedIn has just over 30 pre-built integrations out of the box too. Some of them are paid services that you'll need to buy API tokens for, but some are open data sets that are still of high value. Now, it's only at this point that we start to investigate the whole problem of duplicates, right? Deduplication, entity merging, and this is kind of very similar ways to describe a similar process. Now, if we look at the two records side by side, we could probably, as humans, argue that, well, I can probably normalize some of this data. I can see that the date of births are actually the same, and country is the same, but just in different languages. CPH is a common abbreviation of Copenhagen. Well, the last names are very different, but well, to be honest, people get married, right, and change their names. So just looking at this from a human perspective, I have a relatively high level of confidence that these are the same records. Now, this is still an interesting technique to take, right? And we do at CluedIn use this as one of the ways that we do merge records. So the first approach we're going to take is we're going to run what's called string distance functions between these properties. Now, obviously, something like first name is going to get an exact match. Something like last name is going to get a big string distance. It's going to act as if, well, this is very different values. And to some degree, the same for email. If we weren't to normalize the date of births and things like that, you'll also get some pretty vast string distances. Now, what's so important is that although we do take this approach, you should not be merging records just off this approach. It's quite a naive approach to merging records. And so one of the techniques that we also use at CluedIn is that we actually train our merging engine on generic data and your data. So essentially, we take a whole bunch of records that either we or your business knows is the actual same person, but there's no unique overlap. And we use this training data to be able to build up company-specific models to understand how your data merges. And I can tell you without failure that, data from one company to another, it merges quite different. There are different properties that will allude to a merge. But we're still not done yet. There are other things that we need to do to be able to merge records properly. The key importance here is we're going to use multiple different techniques of merging, and we're going to weigh up the average or the mean weights of the scores across these multiple techniques to be confident with a final merge. Now, it is important to mention that as we're merging these records, we're also keeping a full lineage of what were the records in both sources, because just because one is more accurate or one is the latest value or the latest updated value, just because one's not in a valid email format and one is, that doesn't mean that they're all not correct or all not wrong. And that's why we keep this full history and lineage, so you can always go back in time and see how these records merged and what properties were chosen as the ones that were more statistically confident as being correct. Now, it is just worth reminding everyone on the webinar as we go along that as we're running these different processes on the data cleaning and preparation, we're always shifting these different metrics on these records up and down. So depending on what a different particular process decided to analyze the data, it might say, well, based off what I saw in my process, I'm actually going to decrease the accuracy of these properties or these records. It might increase the completeness because we were able to fill in some data from a particular process. Something like the enrichment, if we look up an external service and it's able to give us the address of a company, well, we're increasing the completeness of that record. So we're still not done with the merging, and I hope this highlights just how a complex problem deduplication and merging of records is. And when we refer to merging of records, we're not only referring to duplicates, we're actually also referring to objects that are just related to each other. If a person works for a company, that's a relationship that exists between that person and that company. And so these techniques here are really trying to solve both problems at the same time. So I mentioned one of the databases that we store the data in is a graph database. Now, we use this as for many different techniques within our processing engine. One of the ones that's really good at is understanding context of data. Because if we take that side-by-side record view that we saw previously when we were trying to fuzzily merge two records, we lose context. We lose context of, well, where did that data come from? What data is related to that? What data is indirectly related to that? And that's really where the merging engine starts to become powerful, because we can take those two records and we can start to look at the records attached to those records. We can start with the direct connections and then we can look at the indirect ones after that. And what that allows us to do is, if we're seeing a lot of things that are similar, that are connected to two records, it can really help us understand that even though these people fundamentally have different last names, using the data around them, we've actually figured out they're the same record. And one more technique in merging that I'll highlight right now is also based off the graph, and that's what's called the shortest path. And what that allows us to do is it allows us to take both of these Emma records, Emma Smith and Emma Fitzpatrick, and it allows us to start using our network, our graph database, to start asking, well, how are these two people related to each other? And when we start to run those queries, when we start to see that a lot of paths are overlapping, for example, they both worked on a similar document, or they're both working in a similar department on similar topics and keywords, that can really also help us boost that even if the data is quite different at a metadata level, but actually at a graph network level, and we're seeing some very obvious patterns that these people are either the same or related. And one of the things that really helps us out with is the unstructured piece. Because most of the time we're solving our unstructured data by only looking at an individual unstructured document itself. And we're going to be running, natural language processing techniques to be able to extract out things like this is a person, this is a company. Maybe you might have gone as far as building dependency trees to break down sentences into something structured. Now, this is great. This is still a necessary process to help us with unstructured data. What you'll find is that you actually get bigger wins out of utilizing the graph with unstructured data. And here's why. If I have reference to an Emma Smith within a document, now really I'd not have to do metadata analysis on that document. Was she the author? Was she a recent modifier? Is she mentioned in the document in any structured way that I could use? And they're all great techniques. But if we don't have those, and it's often that we don't, if we start to look outside the document and we start to say, well, Emma Smith, within close proximity to this document, is there anyone called Emma Smith? And really, this is what helps us figure out more statistically confident that, hey, I think I know the Emma Smith that you're talking about. And of course, if we wouldn't be doing this just off the name. If there's topics that are mentioned in the document that are also connected to this Emma Smith record in the graph, that's more confidence that we can have. That's more overlap in the paths that are happening between this document and Emma Smith. But really, as I alluded to before with the automatic cleaning part, there is no magic to this. There are just some things that with current technology can't be automatically fixed with high levels of confidence. So what about the things that slip by? Well, if you're building a data foundation, there are two roles that are critical to success. And the first starts with data engineers. Data engineers really are targeted at being able to normalize and cleanse data. They don't cleanse data that needs business context, but much more normalizing values that don't need business context. Things like normalizing categories that have in uniform type of, they're not matching in uniformity. And there's a tool that we provide those engineers called CluedIn Clean. Now, one of the keys behind this is that we're telling those data engineers, here's the exact data you need to normalize, because here's the data that doesn't fit the uniformity metrics and the accuracy metrics. Now, the other role that's important, there's a couple of different ways to describe them. There's business users is one, but lately there's two terms that have really been involved in this type of data preparation. The first is a data steward, and the second is a data curator. In fact, some are even now referring to them as data citizens, because really it's about people that are close to the data, don't know a lot about how to clean data, but they know what's right and wrong with certain records. And for that interface, we use an application called CluedIn Train. It's a simple tool that uses reinforcement learning. It falls under the machine learning banner. And really this technique is about teaching the system how to clean data by telling it of historical decisions, something it did right and something it did wrong. The more time you spend with this, you can probably imagine the better it gets at figuring out for itself what is right and what is wrong. So the manual cleaning parts, it's to solve these types of things. What if we have something like TX in what we'd usually assume is the state of Texas. But really, we can't assume these things. Engineers, data engineers need to spend the time. They need to see what are all the possible values that already exist for this column or property, and they need to normalize into something standard. It's unlikely that TX will stand for something like T-Rex, and this is something that a data engineer really can help solve. Now, for the data stewards, that becomes slightly different. Now, who better to fix dirty data than the people that are closest to that data? This is where the graph becomes really important, because if we're trying to answer a particular question, if we have an individual in our CRM system and we're maybe a little bit worried that the quality of the data is not great. So really the best person to help clarify the quality would be the people that either created that record or are associated that record either directly or indirectly. And utilizing the graph, we can actually do this. We can say, here's the particular record I need to qualify. Please find me the people that are closest to this data and ask them the question. Now, in reality, you're probably not going to you're not going to be able to convince the whole business to be involved in this. And that's really where the governance comes in, that there needs to be data owners and product owners that are set for the different integration points. They're typically the ones that it's going to fall back to if we're really wanting to find the most relevant person to be able to help us teach the system about some data. And I guess the best analogy for this is it's really like bringing up a child. If you have a young child and you're trying to teach it right from wrong, you'll probably use many examples of here's something that's right, here's something that's wrong. Touching a flame is wrong, and touching the teddy bear is right. Now, this doesn't mean that I only need to tell my little boy that once. I probably have to tell him multiple times. But the beauty of this is because I'm teaching him and he's learning about what classifies right and wrong. If I was to ever bring in something like a knife, he should be able to make a decision on his own to say, I don't think I should touch that. And that's really the same mechanism that we're utilizing here. It's a technique in the machine learning banner or category called reinforcement learning. We can't also forget that you can be very hands-on with this graph that CluedIn gives out, that you can help correct the data a little bit more visually. If you saw a bad connection between data, that these stewards or curators can go in and prune the graph to reevaluate what is the correct data within the system. So just as a friendly reminder, all along the way, all of these processes are moving the accuracy, the completeness, all of these metrics up and down. And what's important is that the business is actually setting what metrics are acceptable. So often we will have, the CIO, the CTO, the business owner that's defining that, I mandate 90% accuracy of all data that we send out to the consumers. Now, obviously, the higher those scores, typically the more work you need to spend in CluedIn Clean and CluedIn Train to be able to lift the data quality to that level. But the good thing is that the process is facilitated around it, around who's responsible for cleaning it, and here are the consistent tools to be able to provide that quality increase. So the third hurdle, and with around 15 minutes left, I'll really focus on the data access, right? So how do we make this accessible to the business, this data? After all, we've got good, clean, governed, labeled, high quality data. How does the business start to leverage the data foundation? And one of the interesting technologies here that we really are backing and makes complete sense for ubiquitous kind of decentralized access to data is a language called GraphQL. And one of the reasons why this is interesting is because typically at this point, we'll use a language like SQL. SQL is a fantastic language. But we can't forget that SQL is really designed around one particular database family, the relational database. And also, we don't need the overhead of SQL here because we're not doing any joins and we're not doing any group bys or aggregations. That's something that's already been done. So if I wanted to just find customers that earn over a certain revenue limit, I don't need to specify what tools it came from, and I don't need to specify how the data that's scattered is somehow blended. That's something that's already done. And what this means is that we can get access to data much quicker. What's also important is that because we have this data prepared in the different database families, we can now run a GraphQL query that underneath the querying engine, it will actually go off and run what you want against the most suitable database or databases to fulfill that query. So for example, if I said I wanted all mail from Gmail, and for all the entries, I want to go off and get the author, the full object of authors associated to those mails. Now, in the relational world, that's a join. In our world, that's a prepared query, so extremely fast. You could probably imagine what happens if I start wanting the companies that those authors work at and what employees also work at that company. You start to see the limitations of a relational database being able to serve this query, or a NoSQL or document store being able to serve this query. Part of that needs to be done by the graph database, but we could probably find the data that we're after using our search index. And really the value here is how we've optimized this one query language to be able to abstract the complexity of which database should actually fulfill this query underneath. Now, querying data is great. However, more and more, streaming data from a foundation to the target is solving a lot more problems. The first problem is lineage. How do we know where we're sending data? And if we're streaming data to platforms, we have that full trace. We have the trace that down to a particular entity level, we have at some point pushed it over to Power BI or pushed it over to the data warehouse. Now, both techniques of pulling and streaming are still both valid, but really we're starting to recommend more and more that our customers stream data from the CluedIn hub over to the consumer. And really, that is the recipe. That is the recipe you need to put in a data foundation at your business, also known as a data fabric. And really, now once you have these pieces stitched together, you really have kind of a decentralized, democratized access to data that's already taken care of governance, already blended, already cleaned, already high quality, with a process around it to increase that quality over time. And with that in place, really, we can start to get access to data quicker, but also get to the value quicker, because we jump over a lot of the common hurdles we need to solve every time that we need to work with data. And so with this abstraction in place now, that large, complex landscape of a foundation that we saw earlier in the presentation turns more into this, where data comes in, it goes through the foundation, it's enriched, it's blended, it's normalized, it's cataloged, we have a common vocabulary or business glossary to describe this data, and it's much more ready to use in a consistent way. And really, it doesn't matter where the data comes from. It could come from social accounts, it could come from support ticket systems or CRM systems. The core is now that we, as a business, are not thinking about the data warehouse. We're not thinking about data governance and data compliance. We're just thinking about the foundation of data. Please do all the things I know are necessary on the data before I can access it. Things like access control, scalability, where it's located, sovereignty, lineage and auditability of the data. That should all be taken care of from the foundation. So then why even do this? I've put, I guess, a couple of examples together of why would you put in this foundation? What's the value? So first of all, it starts with that your company now has a consistent way to talk to your data. Efficient access, lack of complexity around what systems you need to talk to. And of course, these flexible querying language to be able to get out data and filter it and query it in just ways you haven't been able to do in the past. So then what does it look like once you've done it? A good example is the business intelligence tools. What you'll find is that you're able to deliver much more clean, normalized data to the data warehouse and BI teams. And that classic story is, or that classic saying is, couldn't be truer of, bad data in, bad results out. Unfortunately, we see time after time so many companies fueling these tools with bad quality data. And it only takes a little bit of time for people to lose trust in what these beautiful visualizations are actually showing. Of course, we get to see things like a single view of our customers, a unified 360 view, and utilizing the graph. Of course, this becomes really interesting. We get to search through our catalog of data, find exactly what we're after. This is all available in the data foundation. And of course, we need to, we get to fuel these kind of modern platforms like machine learning. I mean, they also require good quality, unified, blended data. We're not always, these types of projects don't always need data from just one system. It usually comes from a lot of different systems. So thank you very much for spending your time with me today. And if you would like to get in contact to start to build a data foundation at your business, reach out to us at CluedIn.com and sign up for a demo. So thank you very much for spending your time with me today. I hope you have a very nice day. Thank you.